Okay, so I've seen this interesting project, Phasm Raylib demo, and my idea for today is to try to replicate this thing in our cool language. And yeah, we'll use Raylib, right? And we'll try to imitate the same way of calling to external libraries from this project. And yeah, let's see what happens basically, right? So the first thing that we need to do is to declare this as just an elf64, no longer an executable. But if we do this, um, let's try to build our example. It will complain that it doesn't know what segment means, right? It's gonna say it's unknown illegal instruction. So we actually have to change this with section, and here this should be data, right? And we no longer have this one. And here, instead of segment readable executable, we need to specify that it's gonna be segment. It's gonna be section text. I think that should be good, and this one should become public. I think that's how it looks like. But we still have some segments in our code. So if we go into assembler.c and search for segment, we still have these segments. So let's comment these out. Right. They just were separating the methods from the tables and stuff, so I think it's fine to keep all of them executable. Right, so let's see. First we have to make, obviously, and now if we rerun the compiler, it looks like it passes. And if we check out what files we have, we can see that it generated this main.o file instead of our main executable. And it says it's no longer an elf 64 executable, it's something else, right? It's I don't know how you can check with LDD on it. I don't think so. So it says that it's not an executable, right? So what we can do now is to try to link it. And I mean, I tried it before, but let's try to do it just like this. And then try to execute it. So you can see that if we link it with nothing, it just runs. It's not a dynamic executable. I guess it's static if we take a look at it. Right, so it's statically linked. But we can try to use a dynamic linker. And I guess now if we check with LDD, I mean, I'm surprised it doesn't say it's dynamic. But we can add these libraries like LC, LM to it, and this should make it dynamically linked with basically with libc, right? So, and what's funny is that it still works with our example. I mean, it was just some random code that I had in this file. So yeah, and now if we check LDD on it, we can see that it links with libc and libmath, right? So that's pretty nice. So that was from the make file, right? Okay, and in here we can actually use Raylib. Uh, I mean, I think the best way to do it would be to, clone Raylib and compile it on build or something, but we can also just place it somewhere and yeah, link with it. So let's try to actually include something that's external to our code. For example, let's say we are gonna have an external printf, right? And let's define the message or hello is gonna be db hello world, and also the new line. And now if we do move RDI hello and then call to printf, let's just make just in case. Let's go ahead and build. So here it oh, so see it compiles with this external printf here, and main.o is still just that. So if we try to link it, let's say without lc, it should say that it's an undefined reference to printf. But if we add libc, seems like it compiles, and if we run it, you can see the message hello world. So I mean, with this thing in mind, we can try to add the Raylib to our entry point, and let's say at least be able to spawn a window or something like that. That would be really fun. And then we're gonna move that assembly into a class, basically port Raylib to cool language. And I mean, yeah, it is something. I mean, it's not great because now cool is gonna depend on libc basically, but yeah, I mean, yeah, it's still fun. So I've seen that in this project, uh, he already compiled the Raylib like this and pushed it into Git, so I can just steal this folder. And I mean, I already tried it, so I mean, obviously I had to try it just to make sure that it works, otherwise it wouldn't have been fun to. So let's try to actually copy the Raylib folder, and I guess let's place it here, doesn't really matter. But I thought I put an R here, strange. So now we have Raylib, right? Obviously, as I said, I would rather have the project itself or like a Git submodule. Not sure yet, though, how to handle this dependency. But we'll see. Maybe we will get an idea once we have something more. So now we can actually, try to copy from here. Like we can try to get this init window should close, and close window. These are the three main functions that are used to spawn a window, right? So we can take these as external. Then init window, the function, if we take a look in raylib.h for init window, it takes in two numbers and the title. And I think the convention is still with RDI, RSI, and RTX, yeah. So what we can do is, well, I guess let's comment out the calls to, actually no, let's leave them. So it's gonna be move RDI, let's put 800, move RSI is gonna be 800 by 600, and move RDX. Let's have a message db hello world or something, and let's move here the message, and then we can call init window. Then the window should close. In this example, window should close is like a while loop, right? So I guess it doesn't get any arguments, so we can just call window should close. We can call this function, and it should give us in RAX, we should get the result. So we can test RAX, right? And if it is 0, then we shouldn't close. So jump if 0. So I guess if it's not 0, we can exit the loop, right? Exit. Otherwise, we should jump to again or something, and again should be here. And obviously here we do the drawing, right? Yeah, here we should do the drawing. I mean, when we are going to implement it in cool, it's going to look differently, but no. And at the end we call to close window. So here we call close window. So yeah, let's see if we just try to build our example. It compiles, doesn't have any issues. Alright, and if we try to link it only with LC, see it complains that it doesn't find these things. But if we do with Raylib and say that Raylib is in this location, yeah, it tries to link with other stuff. So with libmath, for example, let's add that. Now it actually compiled, right? So if we take a look, we have main. Oh, we can also check LDD. Interesting. And if we run it, we actually got a window. Wow, that's really nice. This is really cool. Alright, I mean, I cannot close it though. So I guess, yeah, I don't know. I guess I don't do any, yeah, I don't know how to close the window. Window should close. I thought escape closes the window, but yeah, who knows. Whatever, anyway, we can, like, now we have this basic example, right? So the idea is to just move these functions into some cool class, and yeah, I guess that's the plan basically. So yeah, let's see how this will work, right? So let's see how this will work. Let's no, I mean, not really remove them yet. Wait, I'm curious. Did the window name? I don't see it. Xprop? Is it Xprop? Yeah, it's Xprop. So is the window name Hello World? Yeah. Okay, so I mean, it seems like it works pretty well. Anyway, so I guess like all the features work for this. I'm not sure how to close the window. To be honest, I never was able to close the windows in Raylib, but that's the other problem. So let's actually create a folder for Raylib, right? And here is where the cool files and the assembly files for Raylib will live, I guess. One last check is, can I define this here? So if I do again a build and then link, then main, yeah, it looks like I can. I don't know why I cannot close the window, but so yeah, this part is not gonna be needed anymore, but we are gonna require these things in our assembly. Well, when we get to that point. So yeah, we leave the entry point like it was before, just calling to our main method, and let's go into Raylib. So here, raylib.asm, we and like these files will all be concatenated, so we don't have to add anything. It's like they are just merged together. They are smooshed into a single assembly file, and this is the first one. So luckily, yeah, I mean luckily it's the first one, so it has the format on top. Otherwise, it wouldn't work. And also, yeah, it's like the section data is here, and then the section text is everything else. So that's also not ideal, but yeah, I don't have a better idea. So I mean, if it works, it works. You know, it just is like that. So raylib.cl. So what we are gonna do is define this raylib class, right? And basically the raylib class is gonna have two methods, three methods actually, and all of them are gonna be external, so we'll have to implement them in assembly. So alright, I guess in cool you cannot start, you can only have, I think it's camel case, so we can only have this. And again, init window takes in a width, which is int, height, which is int, and the title, and it's gonna return an object. Right, it's gonna return an object, and the other feature about it is that it's external, so we have to define it ourselves in assembly. Window should close. It's gonna take it's just gonna return a boolean, and close window is gonna return an object. And I mean, here in Raylib they return void, right? But we have to return something. Well, do they return void? Let's see. Yeah, they return void, but in cool everything has a value, basically. Everything is an expression, so we have to define them like this. So let's do make, right? And let's try to build this. So it's gonna complain that it doesn't find these symbols. I think even a better thing to do is to go into examples, and let's try to make another example for raylib.cl. So this one is gonna be class main, right? Class main. We are gonna have the main method. It's gonna return an object, and I guess let's have a Raylib of type Raylib, and it's gonna be a new Raylib. Right, so now we have the object. We can specify stuff like raylib.init window. It's funny how it just suggests that Raylib from cool. let's make it a better size. So the next thing is gonna be while not Raylib window should close, and this returns a boolean, right? Okay, but I mean this is pool and this is a loop. However, this needs to be in a block because we have multiple instructions. So yeah, we have that. And here, let's say Raylib close window. And yeah, that's like the return type of this is gonna be returned into this. So yeah. Alright, so basically this should just work, right? So if we try to compile this guy, let's make sure that we don't have any errors online. Oh, I don't have anything in here, so I mean we can also try to implement these guys, begin drawing and end drawing. Right, let's see what happens here, like begin drawing and stuff. Curious. Anyway, let's figure it out uh, on our own. So for the start, let's just do a new object. Let's just do a new object. So on line 13, it expected a semicolon. Yeah. Okay, so again, it doesn't know what this thing is. And basically, this is defined in the dispatch table. So yeah. Yeah, what's also really nice about the language is that since it defines the dispatch table, it's going to define all the symbols. So if you forget to define something that's external, it's going to tell you. So that's nice. So let's go back to raylib.cl. Wait, I wanted to go into lib. Okay. So we just have these classes, these methods, right? So let's go ahead and try to implement them. So as usual, I mean, let me just copy paste a comment from here just to alright, so we are gonna have raylib.init window and creates or initializes a window. So rax is gonna contain self, right? And on the stack we are gonna have like window width, window height, and the window title, but it's like we already know it's 8 bytes. I would just say this is an int, this is an int, and this is a string. So again, they are the wrapper objects, so we also have to dereference them and do all that stuff. And how did I already forgot. It returns an object, okay. Returns a new object. But this object doesn't mean anything, so it's also that. So we have Raylib init window. Okay, let's go into, for example, Linux. No, just going into random assembly files and copying from there. Because I just need like this allocate variables and like beginning and ending of the method. So the first step obviously is to try to strip away the wrappers of these objects of int, and string. But first let's do something like the 0 is gonna be new object, right? Just to have something that we return. So for example in int asm we create the object like this. Let me just raylib dot asm just have this as that, and I guess we can use this file like int asm as a template of stealing stuff from. So now we can move like this through between them. Okay, perfect. So as I said, let's steal this, and here we need object, we copy it, we object initialize it, and we store it. So now when we anyway, when we go here on the bottom, when we return the thing, let's return d0. So now the function is basically complete, right? It does what it's supposed to do. It doesn't call to init window yet, so we have to do that. So let's see. Basically t1 is gonna be equal to, I guess, let's see, let's copy this part. Right, so we move into rax the first argument. So let's say it's gonna be q word from rbp plus arg0, and we have the arg0 for like is a constant variable to make our life easier, right? Then we take the int slot and take the value from that int slot. So this is the standard way of taking the value from an int object. So this would be basically like arg0.value, right? That's how we take the value, and let's say we store it into a local variable. And I mean, I store it into a local variable just because I mean, again, that's like the convention I used in almost all the. Then the next one is to take the second argument, place it into arg2, and I guess the last one is to take the third argument. This one is going to be a bit more interesting. It's it's not string slot. It's a string field. Right, it's string field. Prelude asm. It's interesting. It's string field, right? I guess let's take a look into string, how I did here, like for example into t1 I put a new string, right? And here I was trying to take string field, so that's just the pointer. So I think if we just take the string field, it's enough, right? So let's go back. So we take the s, and we move it into location 3. So now we have all the variables. So let's say move RDI the first argument, move RSI the second argument, and I guess at this point they are just bytes, right? So they don't really matter. And finally, let's call to init window. So I think this should be the way to do it. Alright, so I mean we used only 4 variables, so 8 times 4 is 32. Let's just keep it like this. Alright. I mean we don't do anything with the return, but it doesn't return anything anyway. Alright, so the next one, but this time let's... I mean we still kind of have to implement everything, right? But at least this one is gonna be a bit more simple to do because it doesn't take any arguments, or am I wrong? Right, window should close, yeah. So this one is gonna be also a bit interesting. It's gonna create a boolean. So let's take this thing, let's say new bool. Okay, so we initialize the boolean, we store it into there, and this is window should close. So window should close like this. So on the stack we don't have anything. Rx contains a bool object. Checks. Yeah, I mean if key escape, but I don't really have an escape key. I mean I have, but it didn't work for some reason. And here at the end we just return t0. So this one should be pretty simple. So we just call to windows should close, right? And here let's say t1 is gonna be windows should close, right? And I guess, right, so we move into this into t1, and let's set the value of t0. So we have to put into, usually I do Rx, right? Then we add the boolean slot, then we move into, and here I use RDI, and then we move that. Okay, yeah, perfect. So this is how we set a value. Basically, we take the variable, then we take the pointer, or like if we add here, we get the pointer to the value slot. Then we take the value that we want to set into another register and we move it to that address. And this way, I mean, hopefully windows should close returns 1 or 0. Yeah, hopefully that's the case. I mean, sure, we can check it. So let's say it's gonna be bool. So we can do like test Rx, and then set not equal, and then move extended, right? I think. But let's just hope that Windows should close returns 1 or 0. I mean, we can, just window should close. We can try to find it. I mean, it's a boolean here, so raylib.h window should close. Yeah, who knows? Maybe boolean is like 1 or 0, so yeah, hopefully it's gonna work. Alright, so we have this thing, and the only thing that's left, okay, but here we only use 2 variables, so let's specify that. So it's 16. Here is also 16. So now let's do close window. Close window. Close window basically, and here a new object, right? Because it has to return something. Even though here it doesn't return anything, it still has to create a new object. I meant to use this one. So we create a new object. We just call to close window, and we return d0. So let's see. Now, like this is everything. So if we compile with our compiler the raylib.cl example, oh, it's arg0. I think it should be arg_0. So let's see, let's try to search for arg, and then let's use this thing, right? Then we need to say arg and \1. Alright, gi. Okay, I think, let's see. Okay, so it compiled, right? It generated this main.o file again. Let's see. Okay, and if we segmentation fault, right? So maybe we did something wrong. I guess we can try to GDB it and see. Raylib.cl. So in raylib.cl we just define this, and in here we. So my guess is that we did something wrong in init window or somewhere like that. That it gets a segmentation fault. So let's see. So we start I, and then let's step through the program. So okay, I don't know why it looks like that. Oh, does it have to run something else? Like, see, it calls to functions. Like, this is not really in my code. Right, like if I run next instruction, okay, at least that works. So let's see when I get to the actual code. Okay, this looks like my code. Okay, so let's put a breakpoint. Oh, maybe that means, okay, so let's see. Alright, so we have RAX. So this would basically be Raylib.cl. Like I guess putting all the arguments. Let me just see. So it should have on the stack some addresses, right? But why does it say bad? Like if I take a look, examine 40 hex bytes from this address, it's a 7. Size 4, dispatch table, and the value. So I think if we try to look, let's say with Python, what 0x20 0 I think it should be like this. I don't know. It's 800. So it's actually the first argument, so that's good. If we examine this one, it's also a 7, so I would guess it's an int. And this has this size, so let's take a look. 600. So, I mean, it's good. And what's at this address? It's a 08, so I guess that would mean a string. This is the size of the string, the dispatch table for it, the address of the integer that represents the size, and then the bytes of the string itself. So it should be aligned. So if it's 7, it's 1, 2, 3, 4, 5, 6, 7. So it's all of this is the string, right? It has an extra, but it's 61, 52. Like if we try to go into Python and take a look at 0x52, it's R, because we show something like Raylib from core, right? So I mean everything looks good. So if we call to RDI, it's gonna push something, it's gonna allocate some space for our variables, 3 variables only. Or how many did I put there? 4 variables. I guess that's true. It's 4 variables. So let's see. It saves RBX, obviously. It move ups. Okay, so it does the object init, which we don't care about. Let's continue. Here, let's see. Here we should take the value of arg0. So at the end of this cycle, I think, like this thing, we should see 800 in Rx. Yeah, I mean 320 in hex is 800 as we saw. So it puts that value. Then here it takes 600, puts it on the stack. And in the last one we take the address to the string. So, and I guess we put it on the stack. So let's take a look at this one. Examine 40 hex. So we can see it's a string. So can we examine string? Yeah, we have a string there. So really from core. Alright, so now we got to this step. So we move into RDI, RSI, and here we call to init window. So let's breakpoint afterwards. Let's continue. and it got a segmentation fault inside of Raylib, I guess. Interesting. I thought this is how we called Raylib previously. Like when we did it in Prelude Awesome. Let's go back to it. RSI, RDI, RSI, RDX. It's pretty strange. I mean, the other thing we can do is just hard code this stuff just to see if it does anything. And let's keep the message somewhere right here. So obviously let's recompile the code, let's relink it. It still has this problem. Still has that problem. Yeah, I mean, I don't have any idea. This looks a bit like a stuck situation. Minecraft noises. So yeah, this would just be like this, right? Like calling to this function. But it's segmentation faulted. And what's interesting is that in this one, it didn't really segmentation fault. But it's basically the same thing. All the arguments were fine, so cannot say that it wasn't fine on the and let's just try to do this again, see. I mean, we already defined them, so let's don't need them here. So. Ooh, segmentation faults. Oh, because I forgot to relink it, right? So I compiled it, but I forgot to relink. So why would it fail? In the other place. Right, like why would it fail there? Yeah, so like the only difference is we call it from another function. So that's the only difference. So let's try to create another function here, which we can call so example, right? And let's do something like take this, move it into here, and I guess the idea would be to also have all of this stuff first and all of the stuff from the end afterwards, so we can have like an idea of this. And maybe there's some memory allocations that break our code because our memory allocator is like really shitty. So like if it has any mallocs and stuff, mess uh, it might mess with our code. But it shouldn't really, in fact, because we already allocated our memory. So yeah, I don't know. So instead of doing that, let's try to call example. Let's see if uh, it has an issue with being in a separate function. Alright, so at least we found something, like a small issue. I want just to see if in here, I guess it's only one function, right, in this example. So the question would be, what causes this? Right. This is a good question. Let's see if we remove all the RBX and this. If it's just push RBP and that move, if anything changes. Mm, yeah, it looks like this helps. So is it really something to do with the stack? Ooh, that sucks. Is it really something to do with the stack? I don't see how does it affect it. Let's see if we don't do push RBX, for example, if anything happens. Like if we only keep sub and add. So let's, I mean, recompile it. So if we don't push RBX, it looked like it worked. Or am I going crazy? Okay. Okay, so it's segmentation faults because of this push. Then I mean you can change it to like allocate another variable. Like we can change our logic of like here instead of pushing RBX we would just, but I don't see like how does that move keyword RBP minus lock 4 and here we put RBX, so it's the same thing, and then move into RBX, restore self. So it's the same thing. So it has an issue with doing that. Like what the hell? Let me recompile it. Like if we allocate more variables, let's say for example. Okay, now it starts to look random. So if you allocate more than that, okay, I mean that's pretty stupid though. So yeah, I mean we can get around it, not an issue, but I don't understand why that happens, and that's, you know, that's not good. So to go around that, we don't even need variables. Right, we just need to move RDI RX, like, we don't even need the variables. We just need to move into RSI, and the last one is RDX. So yeah. And like we only need one variable for, we don't even need that variable though. We can just create it here at the end. But I prefer to do it like this, if it works. Right. Like if it works, I'll keep it like this. And that's really scuffed. Really don't get why. I mean, the other option would maybe be to create another wrapper that just calls the function. Right? Like that would be my other option, if this doesn't work. I've seen that like with 16 it was working, so okay, so it kinda worked. It crashed after a while, but I mean we managed to get a window, right? So when did it crash though? Did it crash when I try to move it? Yeah. Or does it randomly crash? It randomly crashes. Interesting. So raylib.cl. Let's do something like new io.out string hello world. No, just print something to prove that we actually call it from there. Right, so okay, so now it doesn't crash anymore. But I think it crashes because yeah, I mean it still crashed. Probably we ran out of memory or something. Mm-hmm. Interesting. Like one way to test, let's say, because I would like to test that we, you know, don't run out of memory or something. So let me just remove, because this is like useless, and let's have how can we do that in a way that I can count it, you know? So let's have an integer is gonna be 0, and here we can have a while I is less than 100, let's say, and this just does I equals I plus 1 and then pool. Right, so an example like this main, and if we just link it, whatever, doesn't matter, it just adds one to this thing, right? So we have like an integer and the boolean have the same size. It's 1 byte for the tag, 1 byte for the size, another one for the dispatch table, and another byte for the value. So it has 4 bytes, right? So we create one here. So this is one mem alloc 4 bytes. Then in here this is a constant, so it doesn't matter, but this allocates a new boolean, so one mem alloc of 4 bytes, and this is another mem alloc. So we have in each loop we allocate 4 bytes, right? So we allocate I meant 8 bytes. So initially we allocate 64k memory, right? We have 64k. So if we go ahead and try to do 64, this is how many bytes we have, right? So if we divide this by 8, but we should take this one also into account. So let's do, I would say that if we do like this shouldn't crash in case, right? So I meant to do main. This works, right? But what if we do more, like something like this, more iterations? Still works. So I guess it doesn't really matter if yeah, it manages to allocate memory just fine. Well, something really interesting that I can do in prelude.asm is in malloc 64k. We can have something like I don't even know. I wanted to print a message. Okay, so yeah, I guess it would be, can I do something like message db alloc, allocating more memory quantity. Okay, and external printf. Can we do something like this? And then call printf just to see when it allocates memory. So okay, it didn't like that. So let's go into prelude.asm and try to put it here. Oh, and 10 0. Come on, man. Wait, what? Didn't even print it? That's lame. This was really lame, my friend. Like, okay then, let's try to put it here. I don't understand why I didn't. Oh, I'm compiling the wrong thing or what? Wait, how is it? You know what? Let's remove all the stuff, all the crap. So I was doing the wrong thing probably. So if we do main, obviously I was really surprised that it was so short. Okay, so it actually takes some time, and I guess that's a good sign, because it means that surely it's bruh. Okay, let's try to stop it as and let's take a string constant and call to io dot out string. Like this should work in theory. This should work in theory. We can reuse our stuff. So now we can compile it, we can link it and run it. What? Okay, let's. Maybe I'm stupid. Maybe let's call it after we allocate the memory. I mean, that makes sense. Okay. What the actual hell? Oh, it's because this one should be pushed. Let's push. But should I maybe push the others? To be honest, I don't remember exactly. Oh my. I don't remember exactly though. Yeah, in period.cl I should see this out string. So, I mean, out string gets in a string. Yeah, it's. No, I just wanted to show something on the screen, dude. Let's do classic and move into RDI. Let's move message alloc, message alloc, like that. Message alloc len is gonna be. I mean, this one usually I've seen that it works only like this. I have no idea why. Linux.asm. Let's just copy. Let's just copy the syscall to right, because yeah, why not? Why the hell not? So in RDI we should put D1, which I think is a number. So this should be std out, right? Move RSI. Let me just right. So it's file descriptor, buffer, and count. So buffer is message alloc, and RDX should be message alloc len. Okay, whatever. So this should. Let me just check, man. Std out. Std out is the second one. Okay, sure, whatever. Let's just try this. Dude, come on, what the hell? Like, what the... Can I at least break start? Okay, that's... At least that's the advantage of linking with libc, I guess. Okay, anyway. Oh, this is the copy, right? So let's just go straight into it. Oh, even a better idea. Let's breakpoint malloc. Oh my god, I missed this. What? Really, dude? Anyway, let's just step into it. So jump is not taken, obviously, because it has to malloc stuff, right? Wait, why is it? Why is it still calling to printf? And main. So why was it still calling to? Uh, uh, okay, so let's recompile it and let's run it. Okay, so it prints some garbage. Let's try to go back to doing this thing. Let's do that. Come on. Like, isn't this how you call to write? I thought that's the way to write to call to write. Basically, you put in RTI, you put the file descriptor. File descriptor is the first one. Yeah. Then T2 is the string address, and the third argument is the size. Yeah, I mean, maybe the size was bogus. So let's try again. So, I mean, alright, allo. At least we can see that it allocates memory. Alright, so at least we now know that that's not the issue, allocating the memory. Okay, perfect. So, if we go back into our examples, yeah, this was the test. But this thing seems to be working, right? So for some reason it might crash into Windows should close. It might crash there. But again, I don't see really why. So maybe, as I said, let's try to go back to using all the variables, right? And how about creating a wrapper function for this? Like, I could have here init window wrapper, right? And I've seen that putting this thing and this thing works fine. So let's just imagine that we are gonna do something like this. Just call straight up to it. So that means we have to move into RDI this, RDI RSI, and then call to init, call to the wrapper. So let's see if this changes anything on that. Okay, I used the wrong example, so Raylib. Let's link it, and now, so still doesn't work even like this. Yeah, I don't know what to say. Need window. So like the only option is to use stuff like this, but I don't get why it crashes. Like that's not good. Yeah, that's like really really bad. So I guess we can also try to just do this thing at the end. See if that helps. So we actually don't need any extra variable except for pushing and popping RBX because that's like really needed. But like for example, we don't need those variables. But then again, see, like it's completely random. But yeah, we only need 8. Yeah, at least we get hello world, right? But I couldn't see. Do we also get the window? Oh yeah, we get the window, but it's really scuffed. Okay, let's see it when it crashes. If I don't do anything. At some point it crashes. Can we maybe do htop? See something like what? If it takes up like a lot of memory. Ah, like my guess is that that's what happens or something. But yeah, we wouldn't be able. I was thinking we wouldn't be able to run the tests because well, that's strange. Oh my god, I guess they are already in the temporary folder. Hmm, yeah. Anyway, I mean here we only need wait, we only need one variable as well, but this doesn't really do anything. For some reason it crashes inside of this. In Windows should close. Alright, like obviously, yeah, sure, we can try to run this with GDB and do like start I and then continue until it crashes. And I mean, yeah, we can see that it gets a segmentation fault like somewhere around here. Basically, it's in our code. I see it's in start plus something. So this looks like increment, decrement. Where do we have that, right? Because it looks like custom code. Is it memcopy? No, I can grab 1 second, increment RDI, where I can grab for that. Inc RDI. So it's in this one. Yeah, it's in memcopy. It looks like. Okay, what does it do in memcopy? So this one is the issue. Copy byte to new object. It's probably calling copy. Can you have a stack trace? I mean, so like for example in this one, maybe it's happening. Like this is the only object copy that we have. But then why would it happen? Like we've seen so many hello world messages that makes me think that you know, the malloc works basically. But why would this happen? So tries to copy a byte to the new object. So let's see what do we have in. I guess in object as inside of copy. Where is the copy? So here we take the heap position, store it into T0. Then as usual we get the self size, like that, yeah. Multiply it by 8, store it into T1, okay. Then we add the two of them together. So this is like the heap position plus how much we allocate, plus size of, or how much memory we need for this object to copy it. And if it's smaller or equal, then heap end we can go smaller or equal. Right, I mean I don't really see an issue with smaller than equal though. and otherwise we just memcopy, and we memcopy it into T0 from self T1 bytes. So yeah, like it makes complete sense. Like T2 is the ending, right? So T0 is the heap position, like the start. And let's say we want to allocate, let's say the T0 is at 0 and we want to allocate 4 bytes. So it's gonna be 0, 1, 2, and 3. Those are the bytes that we want to write to. So T2 would be 4. It's like addition between start and size. And I guess let's say heap end is at 4. So 4 is smaller or equal than 4, that's true. So we go to copy. And then memcopy has to copy from RDI, like into RDI, from RSI, this many bytes. So if we go into, I guess I wanted to go into memcopy. Memcopy. We don't have it here, we don't, so maybe it's here. So this one checks if RDX is less than equal to 0, and then it jumps to done. Right, if we want to copy 0 for it. So let's say this one's 4. I want just to see if it goes over by 1 or something. So if this is 4, then this doesn't jump. It takes a byte from RSI, so like from the first position. It moves it into the first position here, so that's good. Increment. So now it becomes 3. Again, becomes 2, becomes 1. Then it becomes 0. I mean, it looks good. The other idea is to let's leave this one run for a while, see if it crashes. Or even better, rather than just doing this, let's also print a message. IO out string hello world. Like this would cause it to go out even faster if it cannot allocate memory. Okay. Actually, it doesn't seem to segmentation fault. But like if we take a look at htop, can we search for this crap? Like it's called main. You see the memory increases. Whoa, it's in percentages. It's 22%. Obviously because we don't free it, but yeah, like it doesn't crash because of memory usage. So at least we know that, right? But it crashes for some other reason. So it was at 3%, not even close. But it still fails in this memcopy part. Right. when it tries to build. And yeah, that's really bad. Like it looks like it crashes here. Let's try to first call to the function and then create the object, and maybe wait, init in window what the so D1 is that. I mean, you get the point. I guess I forgot this, but doesn't matter. So these are all the arguments for init window. Oh yeah, we don't even need this. So as I said, we don't even need to allocate memory, like allocate stack. It should just work. What? Oh, it may be here, yeah. But what is this? So here we create a new boolean, we store it into T0. Here we create, oh, that one should come here. Right. It could also be worth. Nah, not really. Okay, anyway. Let's just try to recompile and run it. See, like it's segmentation faults in this one now because I don't allocate enough stack for some reason. So lame. GDB main. Okay, so finally at least we can break start. Nice. Start. Continue. Oh. Okay. So we can go to this one, and now we can try and find the call to RDI, right, which is basically just creating the window and stuff. So in RDI we have 800, in RSI we have 600, and in RTX we have the string. Right? That's how it should be called. Let me just check here when they do. Okay, so RDI, RSI, and the string. So if we examine string, it's the string, and these are just numbers, so I don't care about them. So yeah, basically let's put a breakpoint on this just so we can get here sooner. Yeah, let's just try it. Okay, so here it's pushing a lot of stuff. Then it's doing a sub, RSP, and then all sorts of random crap. Okay, I can at least next instruction need. Okay, let's use next instruction. What are all these trace logs? I mean, I might as well just continue, you know. RBP minus. Yeah, I don't get it, so like what can I do something stupid like this? And then pop RBP, like have it somehow wrapped around that would be really stupid, but interesting. So at least that fixes the issue with I don't know why though. Like, why doesn't it like this? But yeah, I mean, if it works, it works for this at least. I mean, that's why I wanted to have a wrapper for init window. You know, like take this thing and then have a init window wrapper and just call to it. Here. Call init window wrapper. So shouldn't this be the same thing? But it's not. Oh, because I forgot the ret. But you know, it's I don't think that's the issue yet. Yeah, it's really strange. But like we put these registers, so it's not. Let's see what happens if we GDB it. So let's break on start. Let's start it. Let's next instruction. Oh my god, that will. Whoa. What? Ah, okay. Start. Probably I forgot to do a step instruction. Okay, what? Like it just segmentation faulted randomly. So these are like here calls RDI. I would have seen that though. So no, it just puts all of that stuff. Push RBP, and here it just calls to it. So why would it segmentation fault? I mean, kind of annoying. It's funny how it works a little bit if I put it here, but yeah. Like, at least the init works, right? If I do that. But then it stops in my code somewhere for some reason. Here it at copy. With segmentation fault. So let's try to GDB. Let's see if maybe I forgot to, I don't know, make the stack work or something. So let's see. Actually, let's just next instruction. But why does it already start? Let's just breakpoint afterwards. So the window works, right? And then what's the next RDI call? Raylib.cool. The next call, what's that? Is it should close? I think so. And this looks like it's the print. But it looks weird. So I don't think it looks like that. It was this RDI call. Let's try to skip it. And here it creates an object. I guess it's new IO or something. Can I next instruction over it? Yeah. Okay. something. I want to go and see where the jump is. Like jumping back to... again. And this jumps us back to this. So maybe we can breakpoint at this location. Can we... GDB clear breakpoints. Can we do breakpoint clear? Del, do the del breakpoint. Did. So this is like, if you run it, you know, the stack looks like it's completely fine. But I mean, I cannot do anything on the... So yeah, obviously it just increases the memory addresses of stuff that's on the stack, but again, I don't see how it crashes. Right. So it's segmentation faults in this crap, in memcopy. Yeah, I don't see how. So RDI points to some address. So let's examine that address. I wanted to do this. Cannot access memory. And I guess what do we have in RSI then? But whoa, that's pretty strange. Because see, like RSI looks really nice. Like, well, it was increased, so it sucks. And I don't have a copy of it. So if we try to go to Prelude Asm, I guess it's... should be this one. So memcopy takes everything into these registers. So can I maybe push RDI on the stack just to keep track of it? Push RDI, push RSI, just to see their values at the end. So here I mean pop RSI and pop RDI. I'm curious to see what values did they have in the beginning, basically. And I don't know how to do that in a nicer way, so start. Okay, I guess just continue and please crash faster. Okay, so on the stack we should have RBP is the last one, then we have RDI and RSI, right? Like these are the things that we have on the stack. Or what? push RBP, so RBP would be first. RJ and RSI. So I would say that this should be pretty close to this, right? Like, how much did it increase? Like, if we subtract RSI minus the first one, so if we go in Python and we subtract, I guess, these two, it's 24. And 24, I guess it's the size of an int. Well, it's 32, but you know, yeah, so I guess RSI should also be examine 32. HX should probably, wait, I looked at that. I should have looked at this one. So it should be 0009, which I think refers to Boolean, right? This is the size, the dispatch table, and its value is 0 initially, right? So the first time it's 0. That's good. And this guy refers to RBP, so I don't care about it. And this one is the new address that was allocated. Am I right? So if we examine 8 hex from this, it's also 09 because it was copied into it, but let's try to examine 32. So probably we ran out of memory, right? And yeah, this is what I was not sure about, but just thinking, right? Like starting from this position up until the beginning, it's this many bytes, right? So if we try to divide it by 124 and by maybe 64, we allocated this many pages. So these are bytes. Kilobytes, 64 Ks. So we should have had this many allocations. Yeah, I guess it's really that you cannot have very big programs, but I'm curious. So let's save these numbers, let's just keep them there. Let me just try to go into main, and here instead of 1 quadrillion, whatever this number is, let's do less. Let's do like this, or maybe, I don't know, 10,000. Hopefully that runs fast. So we link it, and let's say we try to run it. So it actually runs pretty smooth. So if we start this entire thing and we continue until the end, I guess let's try to do next instructions, right? So what might be the new address of a new allocation, sort of saying. Like, we shouldn't really be able to examine hippos, right? That's not really a thing. But at least we know that this is the location of the return object, right? There's the location of the return object. And for example, the return object is the last thing from the loop. And like probably is the same address for the beginning of the memory. So it's not even close, right? But I'm wondering why. I mean, it's still a lot of memory allocations, right? But it's not that many. Or why? Like, what the fuck? Like, this doesn't really look right. For some reason. I mean, sure, we can do um, like a lot of bullshit like this, just to try to see what happens now. That allocates a lot of objects basically. So if we do next instruction a couple of times, we get an even bigger address, but it's still not as big as like it's only twice as big compared to this difference. Okay, I mean, I have another idea. This is nice. Person is gonna be x is gonna be an int, and let's have something like this, and we can do a trick like in G Control A. Right, that does that. Okay, so here let's say we create, instead of ints, let's create new persons. Like this is gonna be exponentially bigger. What they do. New person. Okay, I mean, let's see what happens if we do this. Like our compiler doesn't optimize anything, so we are free to break stuff like this. Okay, and this is the new address. Right, so now it's a bit closer, but still not close enough. So let's double it and give it to the next person. Double person, I don't know. Just trying to allocate a lot of memory, you know. Let's do like this. Why not? Put some zeros, and now we can increment it. So this can become double person. Alright, so let's see. Next instruction. Like at this point we are. But this was smaller. But like this is comparable, I would say, with how much we allocated in the other one. So if we do like 3 more zeros, like obviously at some point it doesn't work anymore, but I'm curious just to see how much. Right. Like I'm pretty sure at some point it has to crash because you cannot allocate memory like this. Whoa. Okay, now I kind of have to stop it though. Okay, so it got second. Okay. But like see, like I gotten to 90% memory and it didn't crash yet. So it means you can allocate how much memory you want. Right? It's like it got to 59, which is much higher than what we had in this one. Here we had only 3F. So yeah, it means you can allocate how much memory you want. But no idea why it doesn't like this. Yeah, it can be a bit frustrating to deal with stuff like this, where you just have to debug stuff, but you know, I mean, at least we managed to get the window up and running, even though it crashes. And I feel like we are pretty close to, like, getting some graphics wouldn't be that hard, right? Like, we just have to do the same thing, but for some extra functions, like clearing the background and doing this. But yeah, I mean, I don't want to do it because even if we do it, it will crash like 3 seconds in, so it doesn't have there's no point. So yeah, I mean, I'll just have to figure out where the problem is. So I guess the first issue is why does init window doesn't like having stuff on the stack from the color function. I think that's the first thing. And then I guess why does this crash? But I'll be honest, I really don't want to implement an allocator, like a custom, like make really good allocations. I just want to, but I mean the memory was increasing really fast, so freeing the memory is important. Yeah, I mean we'll see. Because now this seems to work, but doesn't work always, like, so annoying. I mean, this is just basic, right? Taking the arguments were fine. So init window should be fine. But I really don't get why. So, and Windows should close then. This was the other problem. Failing in here in the memory allocation, basically, like where it tries to copy the object, the prototype object. It's like I cannot copy it. So yeah, it's pretty scuffed. Maybe it's because the prototype objects are now in the text section, but there's not really a good way for me to move them into the data section. So I don't know how to do that. Like the other thing we can try to do is to call these functions from this assembly, and not even so let's just try that for a second. But it's still yeah, I cannot really do that. I mean, yeah, literally have no idea. I don't know why this is needed, and obviously that it won't work. Like it doesn't always work. It just happened that it worked for this case. And yeah, and as I said, I don't think we can have multiple data sections. I don't think that's how it works. Excuse me. We can have multiple data sections. I mean, these are just constants, so what? We can have more than one? Wait, what? Wait a second. I mean, that would be, I guess, important. Putting like section in every file like this. But, you know, like, this cannot really be the answer. I mean, if this is the answer, it's pretty amazing in how weird it can be. So I think this can be in the executable section because they are functions. And I guess the other part where I changed stuff was here in this thing, assembler emit, and let's say we put context and we put this guy. So instead of segment. Whoa, 1 second. So readable executable. This is just readable, so this should be data and it's not writable, so just like this. This is also just readable, also just readable. Let's put some spaces. So we have, okay, so we have readable, right? Let's go to the top. So this one is readable. This one is also readable, is for the name table. Readable, executable. This one is executable. This is data. Okay. Like what? I didn't know that you can have multiple sections. I guess depending on the number of sections, it's how many passes it does. Okay, let's not do main. Let's not get tricked. We have to do Raylib. I'm not even gonna say it. I'm not gonna say anything. I'm not gonna say that. Okay, it didn't work. But it felt a bit longer. 6 seconds. I mean, that's above average, if you know what I mean. Okay, so this doesn't help. Whoops. Yeah, so but I guess at least we have a better separation of them. Yeah, like, I mean, come on, let's, just do begin drawing and stuff, just for the memes. Object extern, and drawing is gonna be an object extern, but they have to start with RE, RB, and at least let's have clear background, like, oh, they should take a color. So class color, we'll see how this is done. Man. And the draw text, it should be text, I guess it's XY font size and another color. Okay, I mean, let's go into raylib.h and let's see if they have color. Okay, so color is, but it's chars, so we can keep it in a single int then. That's fine. Whatever. Let's do it like this for now. So if we go into the assembly, extern, begin drawing, and drawing, clear background. Okay, come on. We can do it. So So whatever. Let's see. Not that, but Raylib dot begin drawing. It should really be just that, right? But I really like to have this part here and then call to that, because you never know. I don't know what to say about that. And end drawing should be the same thing, but much easier. Now it's gonna be interesting. Okay, let's add some shitty comments. Now it's gonna be interesting on, whoa, this should be with lowercase b. Begin drawing. So this is setup canvas. I don't really know. I guess this is the comment from the raylib.h file. That's where Copilot takes it. But we need to create a new object. So, wow, that's lame. Well, so return. We still have to create a new object, regardless of. But we don't need memory allocation there. Here we need it just because, yeah, whatever. So in this begin drawing we have to do that. Let's redo end drawing by using Copilot. End drawing. Let's see what's the documentation. Double buffering. Oh, so it just swaps the buffers, right? That's like in OpenGL. That's what it does. Okay. Then we have clear background, and this is the one that's a bit more interesting. Right. So because we need to take our integer and somehow clear background. Clear the background with color, and the stack is gonna contain the color structure. It's 4 ints basically, right? So that's I'm gonna use a string, right? So it's gonna have a string, and the string is gonna be like 4 bytes. So let's go into raylib.cl. The fuck did I search? I wanted to go into raylib.cl. Okay, not this one, the other one. The one from here. So it's gonna have a string, right? And basically the color is saved in 4 bytes, right? So the first byte of the string, or the first character, is gonna be the first color from 0 to 255. Makes sense? Makes sense. And yeah, basically that's the idea. It's pretty scuffed, but I think that makes sense. So we can have an init, right? Like this. And it returns a self type. And how I would implement this method, I guess, is to, let's think about it. So R, we need to convert it to character. So I would do to string basically, right? No, not to string. I need to get a character for it. So I have to do r.chr plus, and here we need to, like chr, if we go to the int.cl, no, Raylib.cl in here, and we take a look at how int works. It has this character function which converts a number into a character. So it does the same as we do in Python. When I say like character 100, it gives us the character. So this is the color 100, and in string representation it's a D. That's my idea. So we convert it to a string, right? And what we need to do is concatenate. Concat with gchr like this. Isn't this really smart? Come on, it's pretty cool. Anyway, so it's gonna be a string with 4 bytes. That's my idea. Okay, so let's generate clear background like this. Let's take all of this stuff. Again, not sure if we need any extra variables. So I would just put okay, let's think about it. So clear background, Raylib .h clear background. Okay, I guess I have an idea, I have a plan. So RA, move into RAX the first argument, right? Then we have to add to RAX this thing is gonna be, well, I guess we can take a look at Raylib.cl. So this field, it's gonna be at the same position as int slot and so on. So we can use int slot for that. But I don't really, I really hate this. So we need to add 24. I would add 24, right? It's the first argument or the first attribute. And afterwards we need to take the value from there. So this is gonna be now a string object, right? This is a string in RAX. So we need to add to RAX string field, and I think that's enough, because now, so let's think about it. So we take the first argument, which is color, right? So let's say field 1 is a string with 4 bytes. So we take the first argument. So this is a pointer to like a color. If we add 24 there is a place in memory, right? And if we go to that place in memory when we do this, when we dereference that, that's a string object. So if we add the value for string field, it's a place in memory with the bytes of the string itself. So the 4 bytes that we need. So I would say that now we have to move into RDI this value, call to clear background, and then return the new object. So to be honest, let's also do put text doesn't do anything for now. Let's just see if this works. Because if this works, even if it works for like what 3 seconds, I'm still happy with it. So this is to do, and basically this is just gonna return a new object, right? This should just return a new object. Clear background. Actually, what if these return self? So we can chain them. So we can do begin drawing dot clear background. Know what I mean? So we can actually chain them together. So that means that instead of doing this this crap, oh, we didn't save RBX. We also have to do that. Pop RBX, and here instead of contains self. So here we move return self. So here we need to push RBX, move RBX, REX, move that, and here we need to pop RBX. Perfect. This thing also needs to push RBX. Do that. And here, whoa, what the fuck? I forgot to say it contains self. So RBX, nice. And here we pop RBX. And obviously for this one, again, it's gonna be self. So here it needs to push RBX, move that. Really move RAX, RBX, and here we need to pop RBX, my friend. RBX, no, pop RBX, perfect. So it's just mocked for now. But yeah, so let's go into raylib.cl, and here why not just raylib.begin drawing dot clear background, and here you need to create a new color. So ray white color is gonna be new color dot init, and whatever, we'll see what happens. So yeah, and end drawing. Jesus, if this works, I'm gonna be amazed. Whoa, type string of the body. Where is this? Oh, in lib. That's interesting. I guess I forgot to do something, so I said this returns self type. Okay, so this returns self. Alright. it worked. Like for a brief second, it worked. So, but it's not really white. RGB. Let's try to make it red. Red, green, blue, and alpha. Like for a brief second, it works, right? But the colors are not right. But I mean, kind of works, I guess. Kind of works. So if we go into raylib.asm, and I don't know, we try to actually implement draw text. Okay, and raylib.cl. Come on. This can actually be insane. So we need a text, we need x, y. Oh my god, it's so many arguments. We'll see. So the stack is going to contain the text, which is a string. It's going to contain x, y, font size, and color. So let's see. We take the first argument, we add string field, and we move it into RDI. Like maybe the issue is that our strings, but no, they are ended with zeros, so I think that's fine. But that's one wondering that I have. Maybe they are not. So like this into RSI. Now let's just leave Copilot do it. I don't know what the next slot should be. RCX, really? Linux syscall register order. One of these posts was the right one. So RDRSI R10. EBX, whatever, that's stupid. So RDI, RSI, RDX, R10, I see. I mean, there's only one way to find out. R10. So in R10 we put that. So here we move the fourth argument. We have to do that. So, well, at least the Copilot learned what. Okay, doesn't know that it needs to use this. Okay, and then we call to draw text. Okay, we just have to go into prelude asm and do more arguments. Let's also do 7. Why not? Like, it's not like I'm using my hands to write, I'm using Copilot. So we didn't draw anything, so it still runs the same the same nothing basically. So if we try to actually, oh my god, you know, let's make it like in Rust, where you put draw text. We don't need that. Like, I would declare satisfied if we see text on the screen. What? Like, why does it matter if it's called from here? Maybe it's because it needs art text and stuff. Like maybe I have to compile it myself. Raylib. But like, come on, it's really looking like it's Raylib stuff. Oh my god. Uh, yeah, I'll just have to figure out why all of this doesn't work. Pretty sure it's... But how does it even know that I'm using draw text? Like if the issue is that, I don't know, it detects that, but here it says loaded. But yeah, that's what I'm not getting. How does it detect that I'm using like draw text and it doesn't work to draw the text? You know, like that's the only thing. Um, okay, one last GDB. So I think this is. I mean, it's not in it, right? Um, I don't think it's in it. In it has a lot more arguments. So I'm not really sure what's this called. Let's go into it, see what it does. I mean, oh yeah, it is in it. But its segmentation falls in the init. And it uses like RBP minus 0xc. And RBP has what value? So print x xmm3. Is this how you print registers? Mm-hmm. XMM word from this address. Print x. I mean, we see this address, and if we do minus 0, we get this crap, and if we do hex on it, this would be the address from where we want to read. So let's see, I don't know, like x 8 hex from this address. So like it's not like it's, I don't know, out of bounds or something. So I have no idea why does it segmentation faults. Yeah, I'm curious because here he used like XMM registers for a lot of stuff. But yeah, I mean at this point it's not really like this was helpful only in the beginning to see how we call to this. Right. But yeah, then again, everything was in start, so it's not like the stack didn't matter here in this case. But yeah, like for some reason doesn't like RBP minus stuff here, but again I see that the memory is available. So even if we do like 40 hex, I don't know how much is a word, but I'm pretty sure it's like, even if it's, I don't know, like 400 hex, it's probably still gonna work, right? So it cannot be larger than that. Um, and what I'm curious is this the first time we encounter XMM though? We can try to see segmentation, fault, seg. (16-byte). Ooh, that's interesting. So it means that the issue is that we need to be 16-byte aligned. Yeah, no shot, that's yeah, here uh, he used like a single int for a color. I mean, that's also an idea, but I thought that being able to create, like from the cool code, to create a color using 4 integers and then merging them together into a single string, because that's the only way we can do it, was a neat trick. But yeah, interesting. So maybe that's something we can try in the next part. We see like this. It's a duplicate. Okay, so like if you know that start isn't a function, RSP modulo 16 is 0, the top of start changes RSP. So yeah, interesting. So like if you remember from some issues earlier, with what exactly? It was with Raylib.asm. Here, depending on how many things we were pushing on the stack, it was getting annoyed, right? So here we were doing push RBX, right? And it didn't like that. So for example, if we do this thing again, right, and try to run it, segmentation faults, right? But now it's segmentation faulted in some other place. But here we only do push RBX, right? But if we push another random thing, let's say we push another RBX, it's gonna segmentation fault in another place, right? Yeah, And I guess this means we have to align our stack somehow. So that's the issue that we have. So that's what I'm understanding. Code on entry to a function, RSP is this. Okay, what people yelling at him for? I mean, it was, although it was insightful to read that. But yeah, move requires data to be 16-bit aligned, 16-byte aligned in memory. That's what the U stands for. The A versus U. Okay. So I guess I'll try to figure out what this means, and next time we'll try to, I mean, yeah, I'll try to figure out how to align the stack, and probably next time we'll have Raylib working, like at least show you how I make it work. But yeah, I'll make sure that I figure out how to do it. So yeah, I guess for now, at least we managed to get a window up and running for a few seconds, but it's not ideal. Like it opens everything but segmentation falls because the stack is not aligned. So that's what we have to do. So yeah, in the next one, hopefully I'll be able to do that. So see you there.